Hey everyone, hope you are doing well. Today I'm going to teach you how to add fractions with a different denominator. So what is a denominator? It's just a number on the bottom of the fraction, and then the top you call it, I think, the numerator, but I can put up a diagram to confirm that if not. But yeah, you got the numerator and the denominator, and you know, to add fractions, now I'm sure there's other ways of doing it, but in the traditional sense at this level in mathematics, you basically get two fractions that have the same denominator and you just add the numbers on the top. And then you can rewrite it. I want to say simplify it, but you're not really simplifying it, or rewrite it to clean it up. That's the general process of adding fractions. But in our case, we have, or in these examples, we have different numbers on the bottom, so you can't just add them together. So what do we need to do instead? We need to change the number on the bottom, change the denominator, and by doing that, we can then add the fractions together. Now, some people might be like, whoa, you can't do that, but you can, because if you change the number on the top and the bottom, you keep the true value the same. So let's say you have 1 over 3. If you times the top by 2 and the bottom by 2, you get 2 over 6. So that is the same as 1 over 3, because I don't know. If it's not obvious, I'm trying to think how to explain it. So 1/3 is, like 33%. You've got a third of the circle full, okay? And 2/6 is the same. So that is 33, or 33.33% recurring. So it's the same thing. You're just writing it in a different way. It's like if you had the number 10, you could rewrite that as 2 times 5. But why would you do that all the time? You'd be crazy if you're like constantly writing 2 times 5. Or if you had a 7, you'd write it as 1 times 7. We're just writing it in a different way. And from there, writing it in a different way with the same denominator, we can add the values together. And it's really just as simple as that. So we've got some questions here that get slightly harder as they go. So 1 to 6, I asked Google, I think it was, for some questions. So I haven't really done them, but yeah, I'm sure I'll be able to work it out. So yeah, let's get into the video. So starting with question number 1, we have a half plus a quarter. So the first thing you have to notice is that they have different denominators. So you've got different numbers on the bottom. Now, the next thing you have to work out is like, what's the common multiple? I don't like all these words, multiple, denominator. I think they overcomplicate stuff, to be honest. But you basically got to work out like which numbers kind of times together or go into each other, so you can have them matching. Like think like, oh, what can I times this by 2 or 3 to make this match and that. And if you can't, for example, if this was like a 3 and a 4, you can't like take multiples of 3 or 4 and make 3 or 4. In this case, we could times 2 by 2 to get 4 and leave the 4 as it is. But in the more complicated ones, you'd have to find a larger common multiple, a number larger than both of them, and times them accordingly to make that number. Can't really think of a simpler way to explain it. Hopefully that makes some sense. So we've got a half plus a quarter. So let's just times this by 2, and we'll get 4 on the bottom, and then we can add them, but we'll have to do the same to the top. So equal to, maybe I'll put 2 times 2 here so you can see. So it's going to be equal to 2 over 4, because that's 2, 1 times 2, and that's 4 on the bottom, plus a quarter. So now we've got 2 over 4 plus 1 over 4, and so it's a quarter or 2 quarters. But I mean, it's probably easier just to say 2 over 4 plus 1 over 4, and you just add the numbers, so it's equal to 3 over 4. And that's it. That's really the basic principle of it all. So let's go through the rest of them, and hopefully the more you do, the more you will get. You can obviously pause the video at times and just try it yourself. But yeah, so let's just do the rest of them. So starting with 2 over 3 plus 1 over 6, well, we can make 3 into 6 if we just times this by 2. So times by 2 times by 2, because I'm timesing it by 2 because I know 2 or 3 times 2 is 6. So that's going to give us 6 on the bottom for this one. So that's equal to 4 over 6 plus 1 over 6. 4 plus 1 is 5. So that's 5 over 6. Cool? And you can leave a comment or question if it doesn't make sense or anything like that. This one's a bit harder because if we times 4 by 2, it'd be 8, and we times it by 3, it'd be 12, but that's not 6. So how do we do that? I guess you could times it by like 1.5, but that's confusing. We're trying to just stick with whole numbers for now. So what's a common multiple between 4 and 6? Well, I'm thinking 12, because 4 plus 4 plus 4 is 12, and 6 plus 6 is 12. So let's times this one by 2, and this one by 3, and then we can add them. So this times 3, it'd be 3 over 12 plus, we'd do 2 for this one. 2 over 12 is equal to 5 over 12. Okay? Times top and bottom by 3, top and bottom by 2. So this is 2 over 5 plus 1 over 3. I feel like they're getting a bit harder now, so I'm gonna have to start trying. 5 and 3, lowest common multiple, and you can write the multiples out. Like you can be like 5, 10, 15, 20, 25. That's the 5 times table, I guess, or multiples of 5. 1 times 5, 2 times 5, and you could do 3, 6, 9, 12, 15. Oh look, bam, we found 15, 15. Okay, what do I need to do to 5 to get 15? Well, times it by 3. What about 3 to 15? By 5. So that's how you can map it out. Let's times this by 3, so this can be equal to 6 over 15 plus 5 over 15 equal to 11 over 15. Cool? Hopefully that makes some sense. Now these are slightly more complicated. You see you've got a 1.5 and a 2 1/3. I think it's called like an improper fraction or proper fraction. But let's say it is called an improper fraction. You've got a whole number and then you've got part of a number. So, you might be asked to write your answer in this form, or you might not be. It depends, but it doesn't really matter. We're just going to change them into I think they're called proper fractions. So let's change them into fractions, and then we'll just do the same technique. So how do I explain this? So a half is 1 over 2. So what is 1 written as a fraction? Well, you can write it as 2 over 2, 3 over 3, 4 over 4. So this is really 2 over 2 plus 1 over 2. Okay? So that is 3 over 2. And then if you've got 2 as a form of over 3, that's going to be where you've got 6 over 3, because 6 divided by 2 is 3. Or you're adding 3 over 3 plus 3 over 3, which is 6 over 3. Don't overthink it. So you got 6 over 3 plus 1 over 3, so you got 7 over 3. That's going to be, so you got 3 over 2 plus 7 over 3. So we've got 2 and a 3. Common multiple will be 6. So we times this by 3. So 9 over 2 plus 7 over 3. I don't know if you can see this too well. Okay, I'll become a hobbit now. Plus 7 over 3. No, because that would be... Sorry. Should be over 6. Because we're timesing it top and bottom by 3, so it'd be over 6. That times by 2 to get it to 6. It's going to be equal to... what's that? 23 over 6. Going to be equal to... I don't think how to explain this. Why do I know it's 3, 5 over 6? Because how many times does 6 go into 23? Well, you got 6, 12, 18, 24. Oh, we've gone a bit too far. So we know it's just under 4. It's just 1/6 less. So we have 5, 6, and 3 left. Okay. Yeah. Well, I guess you'd have to know about dividing numbers, but that's, that'll have to be a separate lesson. And last one, which I would say is easier than this one. So we got half, so let's put them all over 6. So what would that be? That would be 3 over 6 plus 2 over 6 plus 1 over 6. That happens to be 6 over 6, which is equal to 1. So hopefully that made sense. Hopefully it was clear. This is obviously a lower or earlier grade topic in maths. I tried to make it quite simple, but there might be other aspects in there which you don't understand, which is fine. You can leave a comment. But yeah, hopefully it made sense. Hopefully it was clear. And you can let me know if you have any comments or questions. Thanks for watching the video.